Yep. Basketball. I don't go watch other sports. What? A friend? No, I did not go with Miss Nelson. She emailed me today. She likes my homework cover sheet idea. She steals all my good ideas. Did you know the wham chip idea was my idea? I wanted. I wanted. She probably lost. She burned them, I'm sure. So I was going to make cut shape like pie, like the symbol pi. I was going to cut that out of wood. I actually have like a few of them already made. And I showed up like the first day of teacher workshops with these made, and she showed up with her wham chips. And I'm like, she's like, you can't do yours because I'm doing mine, and that's all there is to it. And so she like totally pulled rank on me and just like, fine, all right, whatever. So I just threw mine away. So yeah, maybe I should bring back the pie shapes, huh? Should we do it? If I do that, what's the qualification? Because because by qualification, nobody got one last test. A 95 or better. Okay, Jens, what do you think? Okay. What if every test I give out, say, like 2 pi awards to each hour? No, I don't know. Does it really have to be top two scores? What if it was a top score, but then somebody else who scored super well, like had one of their best tests of the year? Like, so what if it was a 94%? They did really well. I'll think about it. I'll let it marinate in my brain. Let's do math. Calculus doesn't deserve it. Hey, what's the degree? 5. Positive or negative? Up or down? It'll end up, so we'll begin down. Opposite because it's odd degree. I have solutions of 0, 0, 0, 4, and 4. So I have a triple root and I have a double root. Something like that. Gina gave the negative look. Gina, can you share with us your mistake? Oh, you went down after this? Triple root S pass through. Okay, number 7, degree. 4th degree, positive or negative? It is negative. Why, Maddie? Negative x. So we'll end down and it will begin down. I put a D for degree. Maybe I should have put 4, huh? Okay. So yeah, so Michael, because it's an even degree, it begins and ends in the same vicinity. So I got 5, -1, -1, and 2. I got -1, 2, 5. Got a double root at -1. Something like that. I know what I did. I'm just wondering if you know. Okay. The double root is not at 2. It's at -1. Yes. A double root means that at that spot, if you zoom in, it kind of looks like a parabola. It doesn't mean it'll be up. It could be down. Because it starts down, and since there's a double root there, it can't pass through. It does not pass through on a double root. Okay? Number 8, what's the degree? Fifth degree, positive or negative? So it's going to end down. It's going to begin up. So I have 0, 0, 0, negative 2, and positive 4. I'll give you 10 seconds to try to draw it on your own, and then I will draw it. There you go. Is there anybody who made a mistake that wants to share their mistake? Yes, Braden. You had it starting, what? Arrows were backwards, okay? Don't do that. Somebody else? Anybody else have a mistake? Okay, then you try 9, 10, 11, 12 on your own, and after you get them, come put them up on the board. Very good. Excellent job. I would say these graphs are all acceptable. Let's flip it over. We'll try 6 more, and then you can have your assignment. What is the degree for 13? Fourth degree, positive or negative? So it ends down. How does it begin? It begins the same direction as it ends because of the degree. Degree is even. I have solutions of 0, 0, 0, and 4. What do you think? Next one, degree is 4, positive or negative? And solutions of negative 5, negative 5, 2 and 2. Hello. So I have 2 double roots. It's going to end going up. It's going to begin up. Because they are double roots, it will not pass through the x-axis. That's what we have. About 15, what degree? Positive or negative? So it ends up, it begins down. Everybody, as you look at your graph, sometimes you're like, oh, I wish you could redo that. You know what I mean? And there is a kind of a knack to trying to get a gentle curve, a nice looking curve going here. And anytime you draw a cubic, it should be symmetrical to the left and the right. If you were to flip it. So just trying to accomplish that is easier said than done. But the degree of number 16. Fifth degree, it is positive, so it ends up and it begins down. So we have 5 and 5, 1, negative 3, and 0. What do you think? Try the last two on your own. Nope. It's whatever is helpful to you. Oh, you. That one I did intentionally. I've been doing that one with each hour. The other one I forgot. No, that's a mistake that happens on your test. That's I'm trying to draw out your mistakes. So the green are both the correct ones. The red one, I intentionally drew that one wrong. The 18 one, I did not intentionally do that. Okay. Uh, can I show you guys something real small that's kind of cool real quick? Okay, so just watch and as we're talking about polynomials, there's more to polynomials than just what we been talking about right here. And the fact is that polynomials are great because they're easy to graph, they're easier to understand, they're easier to apply stuff to. Just kind of show you an interesting piece here. The graph of sine of x. If I change my window to -1, actually I'm going to go to -2 and +2. So we're going to jump ahead to a little content here that you would see later on in life. Um, but here's the graph of the function sine of x. And you can't see it. So mode, let's be working in radians. There we go. Graph. And that's horrible. So what happened here? Oh, x min -6, +6, and y max min -2 and +2. Okay, describe the shape for me. How would you describe the shape? It's like a wave. Yeah, actually, sinusoids or sine functions actually model the way that you talk, and models the way that light travels, models the way that we hear things, and models activity like say seismic waves, measuring earthquakes, all that stuff. It's pretty cool. Now, here's what's really interesting. When you get to calculus 1 and calculus 2, you learn this. You can actually take a sine wave and you can model it using a polynomial. I happen to know the polynomial, so I just think it's really cool. X minus x to the third divided by 3 math number. Is there a factorial button on here? Anybody? Where? There it is. Factorial. And it extends out even further. You could do plus x to the fifth divided by 5 math probability number 4 for factorial. And I'll even do one more. I'll do minus x to the 7th. If you want to get it exact, you actually need to carry it out, you know, even further. But this is a very good estimation. What's really cool about this is you're going to see how we hopefully get this type of shape. And so an important study in mathematics is that you can take any function and model it as a polynomial. And I'm going to press enter on this guy. Make it a little bit darker. Go to graph. Now you can see it doesn't do a perfect job because it lets go here. Remember, this is a 7th degree polynomial, but it picks up this part of the sine function quite well, doesn't it? And that's pretty awesome that, well, this is the same as that as you carry it out to infinity. Who the heck came up with that? Taylor and Maclaurin. And someday you're going to look at that and you're going to just, your mind's just going to explode. You're going to see it. That's awesome. I mean, it is truly, truly amazing. So, all right, here you go. Here's your assignment. Oh, not that one. We don't know how to do that. There you go. So all the problems we did today, you didn't have to factor. But in your assignment, 23 through 31, you will need to factor those. Those are going to need some factoring. Okay. And that should be it. Oh, there's study guides? I've never looked inside one. What is it?